Welcome to question 3 of the 2007 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 3 we have a diagram that shows the graph of a function with the domain of the real number system. For the graph shown above, sketch on the same set of axes the graph of the derivative function. So the derivative function essentially describes the gradient of a tangent to any point on this curve. So if we go along, we could see that this would have a positive gradient, this would be positive, 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 but getting smaller until we hit a zero gradient, and then it would be negative, 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 until we get to this point where it'd be undefined, and that is because it is a sharp point. And then it would be positive along this section until we reach this point where it would also be undefined, and that's because it's a point of discontinuity. And then along here we would have a zero gradient. So keeping all of that in mind, we can now sketch a graph of the derivative function, or a possible graph of the derivative function. So here it looks like a parabola for the first section, so then a straight line could possibly describe its derivatives. So you could have this straight line here, and we know that it's going to pass through this point where the derivative is zero because there's a turning point on the graph, and then this end point will be an open dot because we're not differentiable at sharp points or end points. And as you can see, the value of the derivative is positive up here and negative down here, which matches the curve. And then for the next section it's all positive and it's constant, so we'd have open dot and open dot, and that would represent the positive gradient along here. And again, we're using open dots at all of the endpoints because a function won't be differentiable at an endpoint. And then finally we said that the last piece of the piecewise defined function had a gradient of 0, so we're going to have an open dot at 3, and then the gradient will be 0 going in this direction. And because the domain is R, we don't stop the rule, so that would also go off to infinity here. So for this question, only a quarter of students received full marks, with 40% receiving no marks for this. So the examiner said that many students had difficulty sketching the graph and including all of the required information. Common errors were drawing the cusp at the point x equals 0 as a closed circle, as well as at the point x equals 3, and not indicating endpoints or showing them as open circles at 0 and 3. So showing endpoints at extreme left and right was also an error, and excluding the section to the right of x equals 3 altogether, so that still needed to be shown on the graph. Some students were happy to draw many-to-many relationships or inverse relations, which was not what the question had asked for. Other students drew only the section from -3 to infinity correctly, and that particular section could also have been drawn with a suitable curve, although we used a straight line to represent it. So the really important things to take home from this question is that all of those endpoints, sharp points, and points of discontinuity meant that it wasn't differentiable at those points, so there needed to be open dots on the derivative function. So for part B, we're asked to write down the domain of the derivative function. So the most efficient way to do this is to start with the real number system and then to exclude the points where the graph had a sharp point, so here, and where there was a point of discontinuity here. So that means we're going to exclude the set of, so in curly brackets, 0, positive 3, as it's not differentiable at those points. Another way that we could represent this domain would be negative infinity until 0, round bracket for excluding, union with 0 until 3, round bracket, union with 3 to infinity. So either of those ways would be appropriate, with the first being slightly more efficient. So this question was slightly better done, with 45% of students getting the correct answer, but students often gave responses that were inconsistent with the graph that they had drawn in the previous part, and as always, the real number system was a popular response regardless. Use of notation was slightly better than in previous years, however unions and intersections were sometimes confused, as well as the use of round, square or curly brackets. So that's important that you know which brackets to use when, so that you get full marks for a question.